Welcome, also from my side. You may see that the title is slightly different from what you see in the printout. That's because we changed it last week after the rehearsal. And the reason for that was that the original title may induce some other expectations than what I'm actually going to talk about. So during the panel just before, one of the guys mentioned that a case that's pretty common is you have like 1,000 DAU in your new game, and yeah, you want to scale that up. So what this talk is about, what you can do if you already have traffic in other games, and what you can do with this traffic to take advantage of your new games. The talk won't really tell you what you can do if you don't have anything in place yet. So you need a user base to use this and to use the predictive analytics that I'm going to talk about. Briefly about me, I work for Vuga. We're a Berlin-based game developer. We've focused on creating regular hits such as Jelly Splash, Pearl's Peril, Diamond Dash. Maybe you've played one or two of them. And I'm currently building an analytics team for Vuga, and we do predictive stuff on a daily basis. And yeah, I want to share some insights with you from that. So I have a structure in the talk, which hopefully is helpful for you to follow through. So first up, I'll start with the motivation, then the actual prediction that we built, and what actions we took based on this prediction, and finally give an outlook on in which other fields or for what other purposes this will be useful. So let's start with the motivation. So, well, here you have our three current big titles: Jelly Splash, Pearl's Peril, and Diamond Dash. And what's our business? As a quick reminder, even though we're probably all pretty well aware of that, we want to get users into these games through marketing and analytics. If we look at the history of mobile user acquisition a bit, we come from, well, it's a long time ago, it feels at least, viral and organic growth for many apps and games. Then it was the times where we would just buy users, get more into targeting at some point, then performance started kicking in, LTV needing to be greater than CPI. And for the future, and already now, I think we'll see more and more data and analytics, both in-game and on the marketing side of things. And during all this time, the cost of user acquisition have been rising. And they regularly peak for Christmas, but also overall, there's a pretty strong trend. So if we look at this picture again and ask ourselves, where are the data actually here? So where's our knowledge biggest? If we look at the mobile players out there, we know three things normally: country, network, and device, which is pretty limited information. On the other hand, if we look at the games, we know everything we want. I mean, that's up to the developer to define what they want to track, but theoretically you can know everything. So while we are a bit like Homer Simpson out there for the market knowledge, we are more like Lisa Simpson when it comes to the games we have in our portfolios. So we know much more, so I want to talk today about what we can do with this data and how we can tap them to get more value out of the users. In a nutshell again, so it's increasingly costly to acquire players. Keeping players is all the more essential for that very reason. And I'll talk about how we can use predictive analytics to do so, and how we can do it where we actually have data instead of being blind. So now let's come to the real prediction, what we actually did with our data. That's pretty much how the company, or some people in the company see me sometimes, I think. And what we wanted to do is to predict churn, which makes sense, right? Because this is why players disappear from the games. So if we look at research, which we actually did, so this talk is a bit more nerdy than maybe the other stuff here. It has been done a lot in telecommunications, where they try to understand how people switch from one company to the other. In subscription services like newspapers, credit cards. It has also been done in gaming, mostly for browser games. And only this year it has been done for free-to-play and highly casual gaming, at least in the scientific world. And we focused on two games. The first one is Diamond Dash iOS. It's a highly casual mobile game. And the other one is Monster World Flash, so actually a browser game running on Facebook. We picked this one also because it has a much deeper gameplay than Diamond Dash, and we wanted to benchmark how well churn prediction works for very casual games versus more engaging casual games. Both have more than 50 million players, and so vast data out there to build your prediction model. Now a brief intro to the games if you haven't ever played them. I hope this works. It does. So this is Diamond Dash. So when you come into the game, you start with this pretty much immediately. You have to do 3 clicks or something, and then you're in the game and you start matching jams of 3 in a very engaging fashion. So nice sound effects. And yeah, basically you do this until you have a high score, and the sessions are timed for maximum 60 seconds. So it's really highly casual, and people normally play it just in between. On the other hand, we have Monster World, which is a bit like a crazy farm wheel. And you have a huge garden like this with all kinds of stuff, and you can harvest plants, you can sell plants, you can craft products, you can use different tools that are outside on the garden. This is actually my own garden, so it's not very beautiful. It's very functional though. And you can also go into another world and so on. So saying all this only to show what the difference between these two games is, and we will later on see what a huge effect this has on prediction, or how well we can predict something for these games. So, but before we can start with anything, we actually need to define what player churn means. So if you look at this chart, which looks maybe, yeah, not right. So what it does, it shows you how many days players have been inactive when they log into Diamond Dash. So the majority of players are down here. They haven't been inactive for very long, so either 1 or 2 days. And especially what's interesting is then less than 2% of the high-value players in Diamond Dash come back after 14 days of inactivity. So almost, only less than 2% have had 2 weeks of inactivity before logging into the game. So we figured that's a decent cutoff point for defining churn, and said that churn to us for this exercise means that the player leaves the game for more than 14 days. The value of the player to the game then is pretty close to 0, or almost 0. And what we did is we used classification. So that means we defined a binary label for the players that was either 0 or 1. 0 in the case if somebody stayed, 1 if they churned. And we focused on high-value players. This is because these guys are more engaged, they have more pronounced activity patterns, and so churn prediction is more feasible. High-value players were defined as the top 10% of paying players. They're the most active and most valuable to us as a company also. The methods we used, now this is probably really nerdy, I think, I don't know, but I'm just putting it out there if any of you want to discuss this afterwards. So we tried out the neural network, support vector machine, logistic regression, decision tree, and the hidden Markov model. Yeah. Just for discussion later on. What we used to evaluate performance, and now this is something that I think will be valuable for you later on if you ever come across data again in predictive analytics, is the so-called ROC curves. This actually comes from the military stuff, where they were doing a lot of classification back in the day. It stands for Receiver Operating Characteristic Curve, and depicts the prediction performance based on the false positive rate, so which guys you predicted to churn but they didn't, and the true positive rate, so how well you actually were able to predict the guys who then also left the game. What's then the key metric we use for evaluation is the area under the curve. It's called AUC. And a random classifier would always be here, so on the diagonal, and have an AUC of 0.5. A perfect classifier is following the edges of the diagram and has an AUC of 1. So all classifiers you apply to your data will always end up between 0.5 and 1 for AUC. This has one more advantage that I'll show in a bit. It's really neat for communicating with product people. So you build your crazy prediction model, and then you go to the game team and you can actually give them the opportunity, like they can have a choice on how big the false positive rate will be. I'll show you that in a bit. But first up, what this means in general is the further up left there you are, the better your predictions are. If we now compare the best performing classifier overall, which was a neural network, for the two games, we see that Monster World is up here and has a better prediction performance, which is exactly in line with the deeper gameplay. and the more pronounced activity patterns. So now if you take this chart and go to the game team, which we actually did, you have the ability to tell them, because what they're afraid of is cannibalizing effects, right? So you want to do something with their players, and they want to know that it's not going to be of harm to the game if you, for example, cross-link them to another game. So you tell them, if we do this, how big of an error can we commit in cross-linking these players? And if they say, okay, if you get 10% of guys in there who are not actually churning, that's still all right for us, which they said, then you just can show them what we can do good for them, kind of. So for Monster World, with 10% of false positives, we can reach 80%, more than 80% of the true positives, which is given by this point up here. So false positive rate 10%, go up, and you see that you get more than 80% of true positives for Monster World. Whereas for Diamond Dash, we only get like half, 50% of the true positives. So seeing this, we decided we'll do something for Monster World, because the prediction is working way better, and the possible negative effect is smaller. Yeah, and that's the action we took. We tried something very simple to prevent churn, which was simple incentivization. So sending out gifts to the players. We gave in-game currency in Monster World. The package size is, of course, also something that matters. It was approximately $10 US here. We did this through 2 communication channels. The first was Facebook notifications, and the second one, email. And we also A/B tested this to figure out if there's actually value in having a predictive model in place and doing this. The A/B test was set up like this. So we had 40% of players in Group A, which was the heuristic group, which reflects what everybody can do without predictive analytics. That means you send gifts to all your inactive players who haven't played for 14 days. In Group B, we did this, and we sent gifts to the guys who were predicted to churn. And in the control, we didn't do anything. So no churn management policy in place. The results are staggering. No, they're not. There was no effect, which is a bit sad. So that's the sad bit. Yeah, we're honest about this, you know. Yeah. So there was really no effect on revenue and churn rate. But now comes the good part. If you look at the effectiveness of our reach out, we see that it's much, much bigger for the guys. That also included the ones who were predicted to churn. So for email, it was more than 5 times as big, the claim rate, and for Facebook, it was, a bit less than 5 times, but very similar. What this indicates to us is that if you reach out to players before they churn, you still have the ability to communicate with them. While if you do so after they left the game, there's pretty much no interest from their side to react to your communication. That means we did the wrong thing by picking incentivization or just sending gifts, which may just be way too simple, but there's potential here in communicating. So summing up the prediction part, churn prediction works for casual games, or at least for engaged segments within your player base. Churn prevention, gifts have limited impact, but you have this improved communication reach. So now, when we come to the outlook, I want to speak especially about 2 things, which is cross-linking and adaptive gameplay. So cross-linking being you send players strategically from one of your games to another, and adaptive gameplay being really that you do something way ahead of the churn event and change the gameplay experience of players. So coming to the outlook for cross-linking now. The case of non-predictive cross-linking looks like this. Let's say we have 3 players that we're looking at. That's their lifetimes. So player 1 has a way longer lifetime than the other 2. Player 3 is having the shortest. Player 1 also has does some purchases in your game, so spends money, which is pretty important in the end. And now let's say you go by a simple rule. You cross-link everybody who reaches level 30. Bam, here. What happens then is you cross-link player 3 pretty much at the perfect time. He's short before he would stop playing anyways. So that's good, but for player 2, if your cross-linking is successful and he actually starts playing the other game and drops out of the current game, you lose half of his lifetime, and for this guy you lose a lot of lifetime and revenue in your game. What predictive cross-linking enables you to do is to figure out each single point where they would churn. So for player 3, it would be the same one, and here you cross-link them at these different points. That means you don't have this potentially pretty negative effect of cross-linking too early and in the gameplay experience of players. So I think this, especially the more we see rising CPIs and the more pricey it gets to acquire users, will be much more valuable in predictive analytics in general. So if we say you have 3 games, or let's say, let's take the example of Supercell. They have Clash of Clans, right? I don't think they're doing churn prediction there from what I can judge so far, but it would, in my opinion, make a lot of sense if they start looking into that and then really through some nice like even build it into the gameplay in some way or incentivize it for the players who are about to churn from Clash of Clans to join Boom Beach. And for a company like that with millions of players, this is really bound to save them millions in user acquisition later on. So of course this only works if you already have a game portfolio, but then this has pretty big value. And it is highly useful for strategic portfolio management. So people or rumors have it a bit, if you read some blogs, that Boom Beach was there to catch up all the players from Clash of Clans, for example. The question now is, of course, somehow Clash of Clans seems to be the better game, so maybe they don't even want to cross-link. But in general, predictive analytics here enable you to bring your players through your portfolio in an optimal manner. And the question what adaptive gameplay holds in potential is still kind of unanswered, and there's also a certain ethical concern because it kind of means you start messing with the gameplay experience of players, and we're not sure we want to do that. I'd also be interested to hear what you think on this. So let's start a discussion. If you have any questions, ask them now. Here you can also reach me through email or follow me on Twitter, and thanks for your attention.
So we have some questions. If you could please wait for the microphone and speak into the microphone for the questions. Thank you.
My question, my name is George Lemnaro from Green Horse Games. And my question is, you spoke about sending emails or Facebook notification by giving people free stuff, like free cash in your game. And this is pretty extrinsic motivation to make people come back. Have you also A/B tested with intrinsic motivation, something like, hey, save the princess? And
what was the idea there? For the intrinsic motivation, I mean, what would you do?
For the intrinsic motivation, like save the princess, stuff like that. Give me a goal, and here's the issue. Come back to solve that problem that you started to solve.
No, we haven't. But this is what I mean by adapt. Well, it's part of adaptive gameplay. That's probably what you can do in changing the gameplay experience without having problems with ethical concerns. So that's a great idea. I do it, and I think this will work much better. But it also requires more effort in implementing that, of course.
Okay, thank you.
Hi, I'm Andre from Asteroids. We do mobile online stuff. I have 2 questions actually. So first of all, I missed a couple of minutes here. Maybe you said, what kind of data do you use to actually use in this neural network and the algorithms to analyze and make the prediction? Is it some genetic data that can be used between all games, like session length, session, how often the session happens and stuff like that? So, or is it something specific to each game? So that's the first question. And the second one, if you believe this stuff can be used to group players in something more sophisticated stuff, like predict if the player will be paying, if he will be a whale, let's say like that, or he will be just a regular player, and in this way, you would be able to treat those players differently. Like to unpaying players, you would show more of an ads, and to other ones, you would make a huge discount for big packs and stuff like that. So,
yeah. Well, first question first, or actually, wait, now I need to remember what the first question was.
What were the inputs to your neural network?
Yeah, exactly. I'm sorry. So there is a lot of generic stuff, which is, as you said, mainly the activity-related variables. For us, it was mainly sessions played per day. I've seen that others also use time since last session, times between sessions, session length overall, stuff like that. But on top of that, so for this we had a time series view, which was the last 14 days of activity before the churn event, the time series of activity metrics we used. And on top of that, we had some single observation metrics, which was then more related to the gameplay. So what's the balance of in-game currency? How high was the accuracy in Diamond Dash, for example? So how well did they play? So kind of the skill element. I think it's both, but just building these models with activity-related metrics already gives you 80% of the value or prediction performance. And for the second question, this is possible for sure. So buyer classification is feasible with similar predictive performance, also depending on the game a bit. But what I've done a bit is grouped revenue by early game activity of players. And what you see is that the top 10 percentile of in terms of the early game activity, later on generates more than 50% of the revenue. So this already is a pretty strong indication that building predictive models there will also work. And then, of course, if you really start tapping this, based on this, you'll start showing ads to these guys. You'll cross-link these guys really early on in the gameplay already, and so on.
Hi, Anwar Dalati from InnoGames. We've done something very similar, unsurprisingly, and we've tried it out over a couple of our games. And just a comment here, more than a question. We've seen better success with competitive games, PvP games, than with PvE or content-based games. So, for example, the one I'm working on is Forge of Empires. It's not so very competitive, and the result was not so great. For other more competitive games, there was more of a potential.
And one question to you then. So result in terms of predictive performance or in terms of cross-linking or incentivizing the players?
Incentivizing them to stay in the game, because you said you didn't have a lot of results there, and that mirrors actually my experience in my game, but not our company experience.
Okay, that's pretty interesting. Yeah, thanks.
We have time for one more question, and then we can see afterwards.
Hello, I'm Gabor from Pixel Federation, and I have a question. Can you turn the 38 slide?
Oh,
sorry.
Somebody remembers slide numbers. That's amazing. They actually have a use. This one?
39. Sorry,
Ah.
I didn't remember.
Oh.
Okay. Just for cross-linking, when you successfully move the player from game 1 to game 2, how do you know he stopped to play and pay in game number 1? Because many players pay in more than one games, and maybe when you successfully cross-link the player in the start, he will pay in 2 games, and he spend more money for your company.
Yeah, so this is of course on.
Do you have some analysis that when you cross-link the player, he is more predictable to stop or play the game or something like that?
Yeah, we have seen cannibalizing effects if you successfully cross-link players. So it's not 100%. This is a stylized model, kind of, just to get the idea what's happening. So it's definitely not the case that they switch from one game to the other and then stop completely. But you do see negative effects if you do this. So because there is some certain amount of time players are willing to invest into gaming, and you can't just extend this by giving them other great games to play. So at some point you always reach, you start having these cannibalizing effects, and this is exactly what this predictive stuff can help you to minimize.
Okay, well, thank you very much indeed. Awesome. You'll be here again, answer questions outside?
Yeah, sure.
Okay,
Happy to do so.
Good job.
Thank you.